You might remember the term unification from a physics class. This is the idea of uniting everything we have ever known about nature and explaining it using a single model. Our universe is governed by four fundamental forces, and unification is seen as, more or less, an effort to unify these under one theory. In particle physics, the standard model successfully unifies three of the fundamental forces: electromagnetic, strong, and weak nuclear forces. The model came into existence in lieu of the discovery of force carriers or intermediate particles in the late 20th century. But it has a glaring omission. Although the standard model explains three of the forces that rule the world of the very small, it does not include the most familiar force, gravity. Let's hold that thought for a moment. We'll come back to gravity in a while. We are going to discuss a framework which has taken the world by storm in the past few decades: the string theory. We know that atoms are made up of electrons revolving around a nucleus of protons or neutrons. And these are made of even smaller particles called quarks. Now, according to string theory, these quarks are not indivisible and are in fact made from tiny strands of energy vibrating and interacting with each other. Here's an analogy to fit in these strands in the big picture. To get a sense of how small an atom is, imagine if atoms is golf balls. There are as many atoms in a golf ball as golf balls would fit into the earth. Now, picture one of these atoms magnified to the size of our whole solar system. Then the size of a tree on earth would be the size of a single string of energy. In other words, the strings are of the order of the Planck length, 10 to the power of negative 35 meters. Like a vibrating string on a guitar produces different notes, these strings vibrate at specific resonant frequencies too. And the frequencies determine the type of particles these strings form. The proposal explains the behavior of the particles from the microverse to the macroverse with consistency, thus unifying the mutually exclusive quantum mechanics and general relativity. But for the theory to be right, there have to be 6 more dimensions in addition to the 4 space-time dimensions we are familiar with. These dimensions are curled up in structures called the Calabi-Yau manifold and cannot be detected with existing technology since they are smaller than the Planck length. Until 1995, there were 5 different versions of string theory, differing on the basis of string types and of incorporation of supersymmetry. In 1995, Edward Witten unified the subtheories by explaining that the 5 different theories were like reflections of one theory in a house of mirrors. This was named M theory, and along came a bombshell, a prediction that there were not 10 but 11 dimensions in total. The addition of an extra dimension allowed a string to morph into something referred to as branes, short for membranes. These membranes could exist in any number of dimensions, and when provided with enough energy, they can even encompass our entire universe. This means our universe is just a membrane present in a higher dimensional space, which consists of other membranes, aka universes. This is a very important notion, as this would lead us to solve one of the greatest mysteries till date. Why is gravity, the force we talked about in the beginning, the weakest amongst all fundamental forces? From common experience, we know this is true. The electromagnetic force, for instance, is 1,00,000 crore times stronger than the gravitational force. Luckily, string theory helps us explain this phenomenon. There are 2 types of strings, one with open ends, like a rubber band cut in half, and one which closes in a loop. Taking a cue from Stanford University professor Savas Dimopoulos, here's an analogy. Consider a pool table representing our membrane, our universe, and think of the atoms and other particles as being represented by the billiard balls. The atoms around us will stay on our particular membrane, just as the balls will always remain on the table. But there is one form of energy which seeps off the table each time the balls collide: the sound energy, which is why we can hear the click when the balls collide. The intent here is that gravity might be like these sound waves, not confined to our membrane, and might be able to seep off our part of the universe. M theory suggests that everything we see around us, like matter and light, is made up of open-ended strings, where the ends of each string are tied down to our 3-dimensional membrane. But the closed-loop strings make up the particle responsible for gravitational force, the graviton. Since these loops are not tied down, they are free to move away from our membrane into other membranes, diluting the force and making it seem weaker. This is the key idea that will help us prove if string theory is, in fact, the theory explaining the way our universe works, or the theory of everything. It's really simple. Pick a few protons and set them on a collision course. When they collide, they produce a huge array of subparticles. But we are expecting the force carrier for gravity, our friend graviton, to show up during the collision, and then vanish immediately too, escaping from our membrane to another. All we have to do then is collect that data from the event and see if the total energy from before and after the collision match up. If they don't, we could deduce from the law of conservation of energy that a graviton was in fact created in this particular collision, which then sneaked out of our part of the universe, thus causing the discrepancy and proving string theory. In a way, we want a law of nature to be broken to make way for another, finally achieving what Einstein had dreamt of: unification.